This is Note Taking Guide 2.5. We're going to do a whole bunch of factoring today. A lot of these strategies we already know, but a couple of them are going to be brand new today. So let's take a look at these factoring strategies. The first thing I want to do is remind you how to take out the greatest common factors. So you're going to just look at these and see what they have in common. I see that they're both divisible by 5, so I'm going to take a 5 out, and they both have an x, so I'm going to just take that x out also. When I'm done, I'm going to say, what did I multiply 5x by to get to 5x squared? That's x. And what did I multiply 5x by to get to a negative 35x? That's a minus 7. So that's how we take out the GCF. I'm not going to do all of this with you today because this is just a ton of work. If you want to see the answers on Mrs. Clark's note-taking guide, you can just go in and ask her to see note-taking guide 2.5, and I will be happy to show it to you. Okay, looking at this one though, so let's just do every other problem here. I'm looking for the greatest common factor. I can see they're all divisible by 7, so I'm just going to take out the 7. 7 times what gives me 7x squared? That would just be x squared. 7 times what gives me negative 21x? That would be a minus 3x. And 7 times what gives me 14? That would be a plus 2. So GCFs are pulled out just like that. Okay, this last one I can see it has a 3 in common, so see if you can pull that 3 out all on your own. Okay, this next section again is greatest common factor, just reminding us how to do it. So I see that both 11 and 33 are divisible by 11, and I see that they have an x in common, so I'm going to take it out. What did I multiply 11x by to get to 11x squared? That would be x. And what did I multiply 11x by to get to a negative 33? That would be a minus 3. So this is my greatest common factor, the 11x, and this is factored form. Okay, this next one right here, I have 2x cubed minus 14x squared. I see they're both even, which means they're divisible by 2, and I see that they all have a minimum of x squareds on them. So I can at least take an x squared out. What do I multiply 2x squared by to get to 2x cubed? That would be x. And what did I multiply 2x squared by to get to a negative 14x squared? That would be a minus 7. So that would be my factored form for greatest common factors. All right, another kind of factor that we learned how to do is called the difference of squares. This is the difference of square formula right up here. But really, essentially what it says to do is it says to look and see if you have two perfect square numbers. If you do, square root the first number, so 49x squared square roots to 7x, and square root the last number, the 4 square roots to 2, put one with the plus sign and one with a minus sign. This next one, when I look at it, it doesn't look like a perfect square yet, so let me see if I can make it look like a perfect square by taking out the 2x that it has in common. If I take the 2x out, I'm left with 4x squared minus 1. 4x squared minus 1 is a perfect square, so I'm going to leave that 2x out front, and then I'm going to square root the front number here, which would be 2x, square root the last number, which would be 1, and then put one of them as positive and one of them as negative. That would be the difference of squares formula. Don't forget to always look for greatest common factor first. This next one is the difference or sum of cubes. I'm not going to do all of these for you again because that's just a ton of problems to do. But I do want to remind you that the formulas right here tell you to use it if it has a plus in between it or if it has a minus in between them. And then we're just going to plug our information into this formula right here. So on this first problem, I'm going to have to decide what my a value is. It would be the cubed root of x cubed, so it will be x. And my b value would be the cubed root of 343, which would be 7. Because of the minus sign, I'm going to be using this formula that's down below here, this one right here with the minus sign in it. So I'm going to do x minus 7 because it's a minus b, then x squared plus 7x plus b squared. B is 7, 7 squared is 49. Okay, the same thing on that next one using the formula with the plus sign. This one right here, it's got a common factor of x in it. So before we can do that formula, I have to take an x out. Here I'm going to get 64, x to the 4th, and here I'll have plus 1. I'm just kidding on that 4th right there. I really meant 3rd right there. Okay, and now this is a perfect square, a perfect cube, sorry about that, a perfect cube, and I can go up and use that perfect cube formula where my a value is 4x and my b value is 1. So leave that x out front and then use your formula. So 4x plus 1. Then I'm going to do 16x squared minus 4x plus 1 when I substitute it into the formula. Same thing on this one, but before you use that perfect cube formula, you're going to have to take out the greatest common factor, which is a 2. So take that out and see what happens. All right, the next kind of factoring we have here to review is what we do when we have 1 out in front of the x squared right here. We don't have to do a box on this. We're just going to put our x times x here to get our x squared. Then we're going to find two numbers that will multiply to a negative 36 and add to a positive 5. So I'm thinking 9 and 4 will get me 36 and 5. It'll be a negative if I can get that to be positive here, and a negative here. They'll add to the right values. Okay, same kind of thing on this next one right here, but before we can do anything here, we're going to have to take out the greatest common factor, which is a 2x. When I do that, I'm left with x squared plus 5x minus 14. And then I'm just going to factor this part right here. Two numbers that multiply to a negative 14 and add to a positive 5 would be 7 and 2 if the 7 is positive and the 2 is negative. Okay. Then we learned that if we had a number out in front right here that we needed to do a box. So the first part of the box has the first number in it. The last corner of the box has the last number in it. I multiply those together to get a negative 60x squared. So I'm looking for two numbers that will multiply to negative 60 and add to a negative 11x. So when I think about that, I'm thinking I could do 15 and 4 if the 15 is negative and the 4 is positive. So I'm going to put 15x here. I'm going to put 4x here. I'm going to factor my greatest common factor out of the top. What do I multiply 5x by to get to 10x squared? That would be 2x. What do I multiply 5x by to get to 15x? That would be 3. What do I multiply 2x by to get to 4x? That would be 2. Check the back to make sure it works. And it does if you put the right signs on them. So I'll have 2x minus 3 and 5x plus 2 as my factors. Okay, I'm going to do the same thing on this next one, but before I can do it, I have to factor out a greatest common factor. The greatest common factor here, it looks like it's going to be a negative 2x. So I'll be left with 10x plus, actually minus, because I missed my sign there, minus, let's see, 10x squared minus 11x minus 6. And then I'm going to have to do the box from there. This 2x is going to be in the front. That minus 2x will be in the front of whatever I get when I do my box. And I'm going to let you finish that one from there on your own. Okay, this next time is called the quadratic type, but this time we have a power of 4 instead of a power of 2. That power of 4 is going to be separated into x squared and x squared. Then we're going to do the same thing we did on the squared ones. We're going to find two numbers that will multiply to a negative 12 and add to a negative 4. So let's try 6 and 2 there. The 6 would have to be negative and the 2 would have to be positive. We're going to do the same thing on this next one, but before we can do it, we're going to have to take out a 2. So I'm left with x to the 4th plus 7x minus 30. And then I would just factor this bottom part right here. So x squared, I'm thinking it has to be 10 and 3 in order to get to 30 and 7. And so the 10 is going to be positive, the 3 is going to be negative. Nothing inside here factors any further, so I'm done. Okay, this next one says factor and solve. So again, we're going to just split this up into x squared and x squared. Find two numbers that will multiply to 4 and add to 5. That would be 4 and 1 if both of them are negative. You think I'm done right here, but I'm not, because I can see that both of these are difference of squares now. And I know that I'm going to square root the front and square root the back of those and do one of them as a plus and one of them as a minus. So this will be x minus 1, x plus 1, x minus 2, x plus 2. So when I solve for my answers, I get x equals positive 1, negative 1, positive 2, and negative 2. All right, this next part is factoring by grouping. This is the new kind of factoring. You've never seen this before. So what we're going to do here is we're going to look at this first equation and we're going to factor the first two items together by themselves. And then we're going to factor the second two items together by themselves. So what do these two have in common? They have a 3x cubed in common. We're going to take that out front and we'll be left with 3x minus 6. And then what do these have in common? These have a 4 in common. So I'm going to factor out a 4, positive 4 even. So I'm going to be left with, all right, I noticed right here that I made a mistake. So let's go back and just start this one over again so that I can show you what I did wrong here. Okay, when I factor out the 3x cubed here, I'm actually left with x minus 6. I accidentally put a 3 there last time. Then here when I factor out the 4, I'm left with x minus 6. You can tell if you did factor by grouping right because you'll have that same stuff inside the parentheses on both sides. And then what you're going to do is you're just going to grab the two parts that are outside of the same, so 3x cubed and the plus 4. It goes in one set of parentheses together, and the x minus 6 goes in another set of parentheses together. I can write it that way because the 3x cubed has to be distributed to that, which it still is. And the 4 has to be distributed to that, which it still is. So really I can write it in factored form this way and it still gets distributed to the parts it needs to be. Okay, this next one is the exact same thing. We're factoring by grouping, so group those first two together. And you have x squared. That's in common. You'll be left with x plus 5. On this next one, that sign right there usually tells you what to factor out, a positive or a negative. I'm going to factor out a negative there and be left with x plus 5. Then I'm just going to rewrite this. This will be x squared minus 4 and x plus 5. That x squared minus 4 though isn't finished yet because it's a difference of squares. So I'm going to have x plus 2, x minus 2, and then x plus 5 for my last problem. That was called factored by grouping. That's where you grab two of them, factor out a GCF, grab the last two, factor out a GCF, and make sure that what you had in parentheses is exactly the same to rewrite it. All right, this next problem right here says, well, this is what we do when we can't factor by grouping. And we've already done this, so I'm going to just be fast and show you a couple of things here and not show you all the work. We're going to list the factors of 15 because that's the constant back there. So plus or minus 1, plus or minus 3, plus or minus 5. We're going to do synthetic division to see if we can find a number that will give us a remainder of 0. And then after we do that, we're going to finish solving so that we can factor the quadratics that's left. This really is guess and check. I'm going to pick a -3 and just try it. I'm not going to show you very much of this, I don't think, because unless I'm lucky and guess it the first time, this is going to be rather rough. So drop the 1 down, multiply, add, multiply, add, and multiply. So this was not right. Let me try, I'm going to try a -5 and see if that will work. And maybe I'll be lucky on this one. If not, I'm going to pause it and see if I can find it. So that multiplies to -5. That adds to 0. That multiplies to 0. That adds to 0. That multiplies to a -25. So that one didn't work either. So I'm going to pause it and see if I can find it so we can jump to the answer. Alright, I've tried all of my factors now and I did not find one that worked, so I'm just going to say that this one doesn't have a factor and go on to the next one. This must have a typo in the worksheet. Okay, so this next one then, if we were going to look for factors, we would do the factors of 48. So positive and negative 1, positive and... All right, on that last problem, I tried all of my factors and I couldn't find one that worked, so I just put that there was no factors that worked. I think there's got to be a typo on this worksheet. So let's go and look at the next one. I've already listed all of my factors of 48. This is a ton of factors to try. So let's wait just a minute here and see if we can pick a lucky one. All right, after trying several numbers, I'm going to show you -4. So -4, I'm going to synthetic divide with it with my coefficients from my problem up here. I'm going to drop the 1 straight down, multiply to get -4, add to get -8, multiply to get +32, add to get 12, and multiply to get a -48, add to get 0. So what I did here was I just found my factor that worked. My -4 worked, which would be an x plus 4 inside parentheses. Now that I have this, I have a quadratic left that I'm going to see if I can factor in order to make that work. So find two numbers that will multiply to 12 and add to a -8. That would be a -6 and a -2. So I have -2 and -6 for my other two factors. This last one right here asks you to solve for x. In order to do that, you're going to have to move everything over to one side together. So you'll have 4x cubed minus 8x squared. I'm going to subtract the 49x over, and then I'm going to subtract the 98 over and see if I can solve this. And as I'm working this, I remember from last year that this worksheet had an error on it. And so this right here needs to be changed to a -98, which actually makes it a +98 on this side. Again, that was just an error on the worksheet that didn't get corrected this year. So I'm going to factor out the 4x squared here and get x minus 2. And then I'm going to factor out a -7, and I'm going to get, I'm sorry, I'm not factoring out a -7. I'm factoring out a -49 to get x minus 2. These are the same inside here, so I get to write the 4x squared minus 49 together and the x minus 2's together. And then this 4x squared minus 49, it factors one more time because it's a difference of squares. I'm going to have 2x minus 7, 2x plus 7. So when I solve this and set it equal to 0, I'm going to get x equals 7/2, x equals -7/2, and x equals 2.